How's it going, everybody? In this video we are going to discuss policy routing using a policy routing as it is covered in the CCNP route exam, and we're going to use similar wording but not exact context that I saw on the CCNP route exam, and we're going to take that, and what we're going to do is we're going to take it based on what I saw in the route exam, similar wording, not exact, different topology, different IP addressing. So you will see this stuff on the exam. There's no doubt about it. They said layer 3 path control. This is layer 3 path control in a nutshell. So the idea of policy routing is actually very simple. And actually I have a documentation right here. This is policy routing. Normal IP routing is destination based on the longest match. So it'll consult the routing table, find the longest match to the destination that it has, based whether it's a /30, a /32, a /28, whatever the router has to do to get the packets routed the most direct route based on the longest match. So I've gotten into longest match routing before and several times, so I'm not going to go into detail on how it works here. A policy routing can be decided based on either the source and destination, just the destination, the protocol type, incoming interface, QoS markings, all that type of stuff. So realistically, there's a lot you can use policy routing to do. Now, policy routing is kind of the CCNP level of path control. There is another level above that at the CCIE level, is what I consider, because it's only covered in the CCIE topics and in the blueprint, and that's called PFR, performance routing. And what that does is it allows you to use policy routing kind of in the same way, but it lets the router decide what's going on. The router makes routing decisions, not based on whatever it's been told to do. Okay, so now that you guys have seen at least a snapshot of how IP SLA works, and I'm sorry, not IP SLA, how policy routing works, and the different ways that it can be implemented, the different types of implementation there are. I shouldn't say the way that you've seen it implemented. But what we're going to do here is we're going to take R4, that's going to be our policy router. And what that's going to do basically is it's going to take traffic from R7 and R6, and based on subnet mask, or based on IP address, as it states inside of the lab requirements, it says the company IT policy states that all web traffic should be routed to R100/0 IP address. So that right there tells us what our set command is going to be. Static routing or default routing are not allowed. All the traffic should be routed out either connection. If serial 0/0 interface connection goes down, IT policy states that traffic should be rerouted to another direction. So that should tell you exactly what it is that should be monitored. So IP SLA is going to be there. It's going to be a very basic implementation of it. So here we go. We're going to jump on R4, and as you can see, I've got everything running. I've got EIGRP running through the entire topology. So if I do a show IP route, you guys can see that it's a very simple implementation. Now, the reason why I chose R4 to be the policy router and not, say, R1 or R3 is because the fact that when you're policy routing, you're typically going to have multiple points of exit to two different ways of getting somewhere. So right now, we have two different ways to get to the 10.13.25 network, which is actually where we're trying to get to. So let's assume that R5, and I believe it's R5, has the... Okay, no, it's not. And config T IP HTTP server. Okay, so if we try to open up a connection to R5, we should be able to open up a connection to R5 no matter which direction we're going. But if it matches traffic, if anything matches, when we do our testing, we're going to test from R7 and R6, and we're going to try to telnet to 10.13.25.5. and port 80. That's how we're going to test our reachability and go from there. So on R4, what we're going to do is we're going to go to global config mode, and we have to match our traffic. So there's two ways you can do this. You can go into an ACL and match the traffic, or you can set up a static route. We're going to go in and we're going to set up an ACL. So we're going to type in IP access list extended 101, and we're going to hit enter. Now, what I would do normally is you can either do a named access list or a non-named access list. A non-named access list is exactly what we're in now. It says NACL, but because we're in an extended access list, we're not naming it. So we could give it a description if we were in the other in the previous mode. But what we're going to do now is we're going to match our traffic. We're going to say permit ? And we want to permit the TCP protocol, because if we match the IP protocol, we're going to match everything. So we're going to match or permit TCP. Excuse me. And what source do we want to match? Well, because there's only one subnet, we can technically match everything. So we type in any ? And what's our source going to be? Well, we can match it and say we're going to match any host, or any destination I should say, ? Now here's the technical part. See where it says EQ right here? It says match only packets on a given port number. We're going to type in EQ ? And then the different port numbers we can match. Well, we're going to match dub, which is port 80. Okay? So now we've matched our traffic. So we just type in do show access list. You're going to see access list 101 sequence number 10 permit TCP any equal to web traffic. Okay, so any other type of web traffic or any other type of traffic will not be matched. So what we'll need to do is we're going to be permitting. Actually, I should go type in permit IP any, because I don't want to IP any, because I don't want to hose things up for other things. So I'm going to type in exit here. Next thing I'm going to do, I'm going to create a route map. This is the only way you can get policy routing to work. And what we're going to do is we're going to type in route map, route-map, ? And we're going to name it, we're going to say policy, because that's exactly what it is. It's policy, ? And we're going to permit. Now, I always permit in the access list. I permit or deny in the route map, because it just makes it easier for administration to do that way. Because if you permit, it's going to be permitted. If you permit deny, you're going to say you're denying the permit. So you're going to be denying the traffic. If it's deny in the ACL and deny in the route map, you're denying it from being denied, so it'll be permitted. So you want to be careful on how you set it up. So permit 10, ? And you're going to match IP, actually I should be using ? address in access list 101. So we're going to type in 101. Okay. Now the next thing we're going to do is we're going to set the IP next hop ? And what is the IP address of the next hop? So that's going to be R1 serial 0/0 interface, which is going to be 10.1.41.1. Okay. So now we set the next hop. Now there is a trick in here, and I'm going to point it out to you now so we see it later on. This is verify availability. What that does is if we don't, that's going to allow us to tag on an IP SLA track object to the end of our route map. And if the route is not working for the manual policy, what will end up happening is when the traffic hits this fast 0/0 interface and it says, okay, I want you to check the route map on that interface, or I want you to check the access list, does the traffic match? What R4 is doing at the same time is it's sending pings, or whatever we decide to set up as the IP SLA responder type. it's sending that particular type of transponder out, or responder, out to R1. If that particular tracking object it fails for whatever reason, then what it'll do is when traffic hits fast0/0, it's going to be be checked against the route map and the policy. If it doesn't match, it's going to go to the normal routing table and then be routed out. Okay, so for right now, we're not going to do that. So what we're going to do now is we're going to go to interface fast0/0. Actually, I'm going to type it. One more thing here. Let's see here. I'm going to type in. I hit the up arrow a couple times. I'm saying inside the route map, but the route map policy permit 10 matches the traffic. Permit 20, any other traffic will be allowed through, because there is an implicit deny at the end, which allows you a little more flexibility. Because if you deny the traffic, it'll won't let traffic in. If you don't put that permit 20 in there with no match and no set, it'll match everything and it'll forward it onto the routing table. So we're going to go to interface fast0/0 and we're going to type in IP policy question mark the route map name, which is policy question mark route map policy question mark enter. Now, any traffic that is generated based on web traffic, and I'm going to show you what I mean by this. Show route map. As you can see, we have our setup here. We're going to do show access list, and there's our access list. We're permitting all other types of traffic. We have 8 matches. So ARP is working. So now we're going to pull up R6. We're going to bring this guy over here, and we're going to say telnet to what is that? 10.13.25.5 on port, or what are my options here? And the port number is going to be 80. Okay. Okay, it's open, so we know it's working. I turn the HTTP server on R5, so we're going to do a show access list, and as you can see, we have 3 matches there. We do a show route map. We have 3 packets are being matched, 180 bytes. So that tells us policy routing is working. Now if we hit Control-Shift-6-X and break out of that, then we hit the up arrow. But we're going to, instead of doing that, we're going to trace route to that. We're going to trace route. I think I could do it this way too. Trace. Okay, that's what I thought. Trace to port 80. As you can see, it's being routed to 10.141.1, and then so it's being policy routed. So we're going to hit the up arrow again, show route map, and we're still getting 10 packets, 600 bytes. Show access list. We're still getting 4 matches. Every other type of traffic is being permitted through, and that shows. Now, it's pretty straightforward, nothing really complex. Now, let's go to our R1 here, and we're going to bring this down, and we're going to bring up R1, because that's where we're sending traffic. And we're going to go to interface 00/0, and we're going to shut it down. Okay, so what that'll do is we are going to, on R6, do that same exact thing. Okay, but watch how this is different. Notice how it's taking forever to converge. So we hit this guy, then it said, okay, well it didn't match the policy, so I was sitting there checking the policy, so it says, I gotta route you somewhere else. So if we hit the up arrow, again, it's matching it's hitting the policy, and it's not getting where it needs to go, so now it says, okay, well, I need to route you elsewhere. So as you can see, it went 10.143.1, which is R3, and then it went down. So as you can see, it wasn't matching the policy. So that's exactly what we wanted. But you notice how it took a long time for it to happen. Actually, let's do a no shut, and we're gonna do an extended ping. So we're gonna do a ping 10.13.25.5. We're gonna repeat, say 10,000 times. Okay. As soon as we hit enter, I'm gonna come up here and do a shut, and we're gonna see how long it takes for EIGRP to reroute around it. Okay. So we're gonna hit enter and then shut. Okay, and there you see it's down. Everything seems to be working though, right? Okay, there goes the neighbor. Now we're waiting for R. Okay, R4 noticed it. Now it doesn't look like it's going to get caught. Okay, well maybe not. Okay, and there goes the line protocol down now. So we should see, I'm hoping anyway, we should see a bounce. But because of the fact that we've cached this information in Ceph, it may not make a difference. So we're going to do a no shut here. Let's see if that... Curiosity kills the cat sometimes. Okay, the line protocol is up. Waiting for the routers to reconverge. Okay, there it's reconverged. Okay, we didn't really notice any drop. So what I'm going to do on here is I'm going to type in config t, type in no IP Ceph. What that does is it takes the caching sequence out. And I'm going to do the same thing here. I'm going to type in shut. Okay, so it's down now. Protocol down. So now what we're doing is we're using process switching. It's actually going to hit the router, or it's going to use the processor of the router to do. Okay, there it goes down. Well, in this case, it might actually work out in our, not in our favor, but it should show you that how quickly dynamic routing will work. Okay. Okay, the line protocol is down. So we're going to have a lot of pings. We should be nearing the end though. It's a lot of pinging. Okay. Well, it's pretty clear to us that that's not the issue. Control-Shift-6X. Okay, so it got through almost 2,000 pings, and we missed one ping. So actually, it did actually bounce, but we didn't see it. So what I'm going to do is I'm going to do the same thing against, but I'm going to type in, we're going to say timeout is going to be 1 second. Because what that'll do is it'll give us the ability to see it in 1 second intervals. So I'm going to do the exact same thing again, but I'm going to bounce the interface after it goes, and we should see at least a drop. So we're going to hit enter. So we're going to type in shut. We should see a bounce at this point. Okay, so it's up again, and let's type in shut. Okay, line protocol is down. It didn't even hang. It didn't even hang long enough for it to notice it. You saw it slow down when it did that. But, okay, that's cool. No shut. We'll bring it back up. Should reconverge pretty quick here. There goes EIGRP. It's up again. So we're going to come back over here, Control-Shift-6X to break off that. So it got through about 1,000 pings. 99% of them worked. So we did miss one ping, but it could be this guy right here. But we didn't even see it actually bounce, which is good. It shows that we're actually going pretty quick. So what we're going to do now is I'm going to configure on R4 how to track an object. If that track object, if IP SLA fails, then it'll automatically flip it over to where it'll reroute to R3 instead of R1 much quicker. So we're going to type in IP SLA question mark, and we're going to set up an entry number. We're going to set up 10 for this guy, and then we're going to type in now as question mark is we're going to say what kind of what do we want it to do? What do we want IP SLA to do? Well, we're going to say ICMP echo. Okay, question mark, and then what's the IP address that you want to match? So we're going to say 10.1.41.1 question mark. And now we can get more specific, but we don't have to do that. And we're going to hit enter, and then question mark. And how do we want to monitor that? Or actually, right, and how do we want to monitor it? We're going to type in, we're going to set the frequency to, I think that's in milliseconds? No, in seconds. For 5 seconds. So every 5 seconds, enter, question mark, and then the timeout, question mark, is going to be how many milliseconds? We're going to say 2,000 milliseconds. So that's 2 seconds. Enter. So now what we're going to do from there is we're going to hit exit, and we're going to type in IP SLA monitor question schedule it question mark, and then what entry number we want to schedule, 10 question, and then we want to set the start time is going to be, I like that, now question mark, and then the lifetime is going to be forever. We can set up to whatever, it sets it up for an hour, but we're going to set it forever. Okay, now if we come out of here and we do show IP SLA statistics, right now it's successfully pinging R1 serial interface from R4, so we know that's working. So now what we're going to do is we're going to jump back to R4, and we're going to type in route-map policy, and then we're going to set permit 10, and what we're going to type is we're going to set the IP next hop is going to be 10.1.41.1 question mark, and verify availability, I should say. Verify availability, question mark, and what's the IP address of the next hop? 10.1.41.1, question mark. Now, what we're going to do now is you're going to set a sequence number to insert into next hop a list. So we're going to say 1, question mark, and then track, question mark, and what is the tracked object number? 10, question mark, enter. So now we can do that again too. We can set it up, we can go this, and if we had another next hop, we can do 20 and then question mark, track object, and if we had another track object, we can keep going and going and going. But we're not going to do that. So now if we do an end and we do a show route map, it's undefined, but at least we have it. So if we do a show, actually I should say config t and track question mark, and we're going to track 1 question mark and RTR. We set the IP SLA, the schedule, and now we have to track it. So RTR question mark, and then what's the entry number we're going to track? We're going to track 10 question mark, and we're going to leave it at the defaults. So, and we're going to do show track question mark, and track number, what did I name it? 10, 1. track 1 question mark. Right now it says response time reporter 10 state is up, 1 change lasts 21 seconds. Latest operation code return is okay. We can do show IP SLA statistics or stat, and right now we're okay. We've got 37 successful pings. Remember, we had that show track 1, so we're tracking an object, show route map, and it says it's undefined, but we still have the track object in there. So now what we're going to do is we're going to bounce this interface. Okay, and what that's going to do is we're going to do some traces once we do this. So we're going to do a shut command here, and so the neighbor's down now, and any moment now we should be getting word. Okay, so the tracking state is down, the neighbor is down, so it notices that right away, and much quicker than it was before. So now we're going to type in, hit the up arrow a couple times. I believe we just telnet to this guy, or trace. Now it's going 1047.6.4, which is router 4. It's not getting anywhere, so it goes 10.143 to get to where it's got to go. Hit the up arrow again, and we're getting there all day long. Now if we do an up arrow and we hit no shut, bring the up arrow again, or bring the interface up, IP SLA comes up right away and says, okay, I can ping it again, and we still haven't seen EIGRP converge, but that's okay. We're going to hit the up arrow, and now we're going 10.4.41. So now EIGRP is reconverged. It reconverged faster with IP SLA and policy routing than it did any other way. So now we've got an open session. So if we were to telnet to that IP address, now we're open. We can actually go in and telnet on port 80, so we know it's working. Or Control C. So we know everything's working appropriately. That's how you do it. And so now we're going to come over to R4, and we're going to hit the up arrow, show track 1. Let's see here. And we had 9 failures, and now everything's good to go again. So that's that. Now show route map. We have successful 2,900 packets went there, 330,000 bytes. Everything's working. And then show an access list up here. We're getting plenty. We got 25 matches, 5,000 other matches for everything else. So now we know everything's working. So that is IP SLA and policy routing in a nutshell. This is very similar to what I configured in the CCNP route exam. So for those of you that are unfamiliar with how everything gets set up, I recommend running through this a few times. Now you're going to see me use this topology and a couple other videos. So for those of you that are not sure on how to do things, I'm going to use this video for several other things. So we're going to track on how traffic would go from point A to point B, and I'll do some debugs when it comes to setup, and because I want to actually do some testing, because some of the questions on the exam that I got I wasn't too sure on, so I want to go back in here and actually verify those things that the questions that I chose as my answer. And the idea now is, to get a deeper understanding. I feel like I'm at the CCNP level, and I'm going to be spending some time on this, a little more time on BGP, and some more time on IPv6, and go from there. And then CCNP switch and CCNP T-shoot. As most of you should know, I am studying for my CCIE in routing and switching, so that is the reason why I'm in here building these larger scale topologies and setting this stuff up so you guys can see how everything's working. I hope this has been informative for you, and I'd like to thank you for viewing.